100 years to connect 1 billion places, basically with wired telephony. Then it took another 25 years to connect 5 billion people with the whole mobile phone revolution. And now the forecast is that it will only take 15 years to connect 50 billion things. So things are speeding up. I think showing this picture, I often say that you should enjoy today, because this day today is going to be the slowest one of the rest of your life. Things are, I mean, we can see everywhere. It's really internet driven. I mean, we have things like YouTube, we have Airbnb, we have Uber. Everything is going digital, and with digital, you lower thresholds, you increase scale, you speed things up. Of course, up until now, the majority of the connected things have been phones, smartphones. I mean, there are like 1.5 billion manufactured every year. So they have been the dominant thing to connect so far. But they are now rapidly being overtaken by other things. Everything from electricity meters to refrigerators to cars. And the forecast now is that things will overtake phones in 2020, 2021 sometime. So it's a fairly steep curve. And as you know, I mean, the number of smartphones or mobile phones being manufactured, that's sort of stabilized around 1.5 billion a year. But things that will just continue to go up. And I think Lenora has played a very, very important role in this I mean, ongoing revolution that we're actually just in the beginning of. Earlier, as I said, the connected thing was a phone. And I think, I mean, that's really where Lenora was very much born, in the need for consolidation and standardization in software. Taking all this software that wasn't really differentiating and joining forces in creating that and sort of creating this win-win situation where device and also chipset manufacturers could sort of you create this co-opetition setup where you can pool resources in areas where you don't really differentiate, and you can spend your precious resources on places where you do differentiate. So that's where Lenora started. But now in the new, in the sort of the new world where everything gets connected, I mean, Lenora follows, of course, or leads maybe in this case, and all these new groups that are being formed or have been formed in Lenora, they are super relevant in this new context. Because as I said, it's not just about smartphones, it's about smart things. And they're all going to be connected somehow. It doesn't have to be through a mobile network, it can be through any wireless or wired technology. I mean, there are lots to choose from, actually a little too many to choose from. And this is also creating a completely new ecosystem for devices. So what does this sort of digitalization of society mean? Well, an interesting observation I made is that almost, regardless of industry or sector, you sort of follow through the same steps when you digitalize. And the 3 steps I've identified is really that first the infrastructure model digitalizes, then the operating model, and then finally the business model. I'll give you an example of the music industry. I think that's the most obvious example, actually. Back in the 80s, the CD record was invented by Philips. And that became very popular quite fast. I mean, it gave I think partly because it gave it gave you a good user experience. It was easy, you didn't have to turn it around, there was no pickup. It's sort of mechanically more easy to handle, but it also gave you sort of a digital sound quality, and you didn't have to clean it, and it was sort of lots of practical benefits. That did not change the record industry. I mean, it created a digital infrastructure for the music industry, but it didn't change much. You still went to a record store to buy it. You still had a sort of a separate player in your home and so on. The next step, that was really enabled by the first step, came later. That was when the operating model changed. That was basically the birth of iTunes, when the music started to become something digital that wasn't really physical anymore. Now you actually started buying songs off the internet. You bought it in a web shop. You didn't buy an album anymore, you could buy songs one by one and so on. What happened now there started to be disruption in the market. Now record stores disappeared, sort of the whole sector started to change. And then, of course, the final step where the business model changed is that's the birth of Spotify, the all-you-can-eat subscription. You don't even buy a record anymore. You don't even own a song or a record anymore. It's something that you just consume and you pay per month. So these are typically, I mean, these steps can be applied to almost any industry. I think banking could be another one, although we haven't reached the third one yet in banking. The first one is when, back in the 80s, if you remember, if you were born then, you had a bank book, a physical piece of paper that contained your money. If you lost it, you lost your money, basically. Then in late 80s, the banks started to digitalize, and your money was no longer in a piece of paper, it was in a computer in the bank office. Again, not much change. You have to go to the bank office to get your money, you have to go there to pay bills and so on. A little later, internet banking came, and now we're in the next step, the operating model. Again, things started to change. You could do banking over the internet. Bank offices changed character or closed. They became sort of advisory rather than executionary. And there was this sort of disruption to the whole way banking worked. And now I think the next step that we haven't really reached then yet, to be honest, that's when you introduce new currencies that does not even involve a bank. I mean, cryptocurrencies, where you could do international money transfers without even involving a bank or things like that. But that's still to happen. So digitalization of industries and public sectors as well, for that matter, they have a lot of impact on how they operate and the way they are experienced by the users. One interesting thing is customer intimacy. For instance, one of the biggest problems today for the car industry is that they can create a relationship to the first buyer of the car. I mean, they meet them in the shop, they get their name, their address, everything. Sometimes they even have a sort of some kind of financing plan. Then the next owner is typically unknown to the car maker, and there is very little chance of him ever making a relationship with that customer. If the car is connected, it's a completely different ballgame. Now you can offer services, you can create a relationship to that second or third or even fourth owner of that car. And this may sound sort of small and marginal, but it's actually a huge thing for the car industry. Another thing is remote operation. Suddenly geographical distance means very little. If you need, for instance, a really skilled worker or someone who's driving some kind of very advanced machinery, like an excavator, for instance, something like that, you can actually hire that person 100 miles away because you can run that remotely. Continuous everything is another concept that is becoming relevant now in the digital world with cloud, with services being implemented in the cloud. There is no concept of releases or new versions. It's sort of a continuous flow of new features and improvements and so on. This is also a completely different way of developing software, and of course that has impact on organizations like Lenora as well. So overall, we can see all these different industries and sectors transform now. And it's really going very much from delivering things and services into value. And value is in many industries actually a very abstract concept. But I think one thing that is common for all of these changes is that software is that's the center of everything. Things are turning from physical things into software. So this is of course all interesting, and some is scary, some is exciting. But what role does 5G play in here? Well, 5G is sort of the next generation of mobile communication. I'm sure you all know about 2G and 3G and 4G now. That's sort of spreading all over the world and giving you a better internet experience in your phone. And that's all and well, but 5G is actually much more than just a faster internet in your phone. With this development of digitalizing society, there are really two factors that play the most important role when it comes to your ability to digitalize and connect things. One is the latency. I mean, how fast is your connection? If you want to remotely control, again, an excavator or a bus or some kind of machinery in a factory, you need to have a very, very short delay in that communication. In industrial automation, that tolerable delay can be down to a single millisecond. The other thing is reliability. If you want to control a remotely, like a bus in a city, if you want to remotely control that, that communication has to be super reliable. You don't want that bus, you don't want to lose control over that bus so it runs over people or something like that. Same thing with remote medicine, for instance. You may want to be absolutely sure that you have this connection all the time. And here are some examples in this picture now of different uses for connectivity and the respective needs or requirements on both latency and reliability. And as you can see, the industrial control loop, the sort of the machinery in a factory, that's sort of one of the extremes here. Whereas in the other end, we have the sensors. I mean, sensor, if you want to sense the temperature in this room at 8 positions once an hour, I mean, if you miss one, I mean, it's not the end of the world. You pick that up the next hour. So to create this sort of massive digitalization of the world, basically, you need an infrastructure. And up until now, we've seen that many industries and sectors, they do digitalize. I mean, you have digital factories, you have digital houses and living. But what is the big problem today is the fragmentation. There are lots of special systems. There are systems for controlling the temperature in a room. There's another system for the security. There's yet another one for the video cameras, the surveillance cameras, and so on. And this fragmentation and multitude of solutions, in a way, is actually holding back development. It's creating a complex value chain. It's creating incompatibilities. And it's also feeding a lot of players in the value chain, actually, who live off the fragmentation, which is sort of holding back the scale of the growth itself. So in 5G, and I should say, I mean, this is not an Ericsson invention. This is something that the whole telecommunication industry is behind. So, I mean, it could be someone from Nokia or from Huawei who will also say the same things as I do now, because this is something that we believe is sort of a world need. This is, of course, so we're talking about a single infrastructure, and the reason for this single infrastructure is really to create this massive scale and to allow the Internet of Things and the connectedness of the world to grow more rapidly. So the ambitions for 5G are set. I mean, that's done in organizations like 3GPP and NGMN. And we're talking about a massive increase of data rates. So in a way, it is a better internet. It's a better mobile internet, but that's not all of it. We're talking about massive, being able to cater for a massive number of devices compared to today's system, reduce current consumption or energy consumption of the devices, and also increase security, of course. To do this, you of course have to rely on a lot of new technologies. And I'm not going to go into detail here, but they were talking about very sophisticated radio technology. We're talking about beamforming, multi-layer MIMO technology, overlapping cells, very sophisticated software in the network, and also a lot of software in the devices, of course, to create this extremely efficient use of the spectrum, the radio spectrum. So the ambition with 5G is to be not just a mobile phone system, but actually to be the digital infrastructure for the networked society, the networked world. So when we then introduce it, of course, I mean, 5G is not here yet. We're still, I mean, the industry is still rolling out 4G. Not even the entire world is covered by 4G today. The first 5G networks will there will be trials starting already next year. But they will, of course, be pre-commercial. The forecast now is that the first real commercial deployments of 5G will be in 2020, 2021. But already now, a lot of industries are sort of starting to make use of the features of 5G. And you will start to see features of 5G in the networks already now and next year and so on. The new radio communication standard and so on, that will not be until later. But there are features that are being deployed in the networks already now. There are a number of companies, and of course Ericsson is working very closely with different industrial partners to make use of these technologies. One such example is Volvo Cars. And I would call them a change maker because they are at the forefront of digitalizing the car industry. Today, every single car that leaves the Volvo factory is actually connected. It's managed by an Ericsson system. So they're all connected to the same cloud. This enables Volvo to create a customer relationship with their customers. As I said, not just the first, but the second and the third as well. It enables them to do advanced analytics, to offer better service experience, and maybe also with time to offer other companies to offer services to their clients. Another interesting example is Maersk, actually the world's largest shipping company. It's an interesting story because a couple of years ago, they came to Ericsson and asked Ericsson to create a mobile network on every ship. A ship like this, huge ship, carrying thousands of containers, actually just have a staff of maybe 10, 15, sometimes 20 people. So it actually happens that they don't really get lost, but they lose each other. They actually have to phone each other to find out where they are. And also, being at sea for months, I mean, it's kind of a social problem not to be able to connect with your family and so on. So Maersk was actually they were asking for Ericsson to put mobile phone coverage on their ships and then have a satellite link. And that was, I would say, the start of the snowball, because Ericsson did that. But once the boat was connected, they realized that there were so many things you could do. To start with, you could track the ship. The ship could actually tell the central control office exactly where it was, and at sort of constantly keeping the central the headquarters informed of its whereabouts. And now you realize that, well, you can actually start to use that information. You can, because one problem in the past, I should say, is that when you run a freight ship, you get a certain allocated arrival time at the port where you're going to deliver your goods. And the typical behavior of the captain in those days was to run full speed to the arrival port and then maybe wait for a day or two to be allowed in and unload. That's really a waste of fuel, of course, and of time, of course. So what Maersk found out was that when they now could accurately track exactly where all the ships were, and they could correlate that with the planned arrival time, they could actually pace the vessels so that they would arrive only a few hours before the allocated arrival slot, and they didn't have to wait, and they could keep a lower speed in transit, which meant they saved an enormous amount of fuel. With that, and also the fact that they could actually supervise many of the containers on the ship containing sensitive stuff like, they call it perishable goods, basically things like fruit or frozen things like that, because they could supervise that and do that remotely, and even reroute ships where the cooling equipment broke down. They saved an enormous amount on insurance policies too. So this entire investment actually paid off in less than a year on just fuel savings and insurance fees. And this was a completely unexpected outcome of this project. A similar interesting experience we've had in a project where we worked on digitalizing a mine. This is the Kankberg mine up in North Sweden, run by the Boliden mining company. And the initial idea here was, again, just to put cellular coverage into a mine. Again, there was the same problem as on the ship, that people lost each other. I mean, a mine like this has maybe 50 kilometers of tunnels and a staff of maybe 100 people. So they are very, very far apart. And in the past, you have to walk up to one of the wired phones on the wall of the tunnel and call and see if someone answers in the other end. And that was not a very efficient way of communicating with your friends and your colleagues. So Boliden asked us to put a cellular network into the mine. And we started a research project because we felt this was really interesting. So we had this long list of companies and research institutes and so on joining in. What was interesting to see is that when we had this mobile network into the mine, things started to happen. Ideas started to come up. So after just a few months, a lot of the employees, together with the researchers, had come up with a lot of different uses for this network. So once the infrastructure was there, the creativity started to flow. One thing, I mean, a little like the Maersk ship, I mean, location of things was found to be a very valuable feature of this network, because also the big machines and the big vehicles in the mine became connected. You could actually locate them. And believe it or not, you can actually lose a 20-ton mining truck. And being able to find that again, while the driver is on vacation somewhere and cannot be reached, that's actually worth a lot of money. So during just a few months of using that network, all these use cases were identified. I mean, the emergency doctor, for instance, that in hindsight, they're all obvious, of course. But the emergency doctor was interesting because there was an accident in the mine, and because it was deep down, it would take a doctor. Of course, the first thing was obvious, that you could actually call for a doctor right away. I mean, just that has a big value. But then, of course, because the mine is so deep, it would take the doctor maybe 15 minutes to get down there. But with a mobile phone, just a regular smartphone, you could actually take some pictures, and you can even stream a video up to the doctor on top. So he could give some first advice on how to treat the wound. And this is, of course, of immense value. Well, there are a lot of other use cases as well. So, but we didn't stop there. So in Ericsson, we also have started a big European program to help industries digitalize. And one particularly successful such program is in Tuscany, northern Italy, where we have been working with the local government on digitalizing vineyards and industries, and in this case, actually, the port of Livorno. So I'm going to show you a small picture a movie of that.
Intelligent vehicles, so they can broadcast information about their cargo. they can enter some control area using permission. You can have a talking container saying, I want that driver to be picked up by that semi-trailer and I want to be temporarily stopped in that area. I would say that 5G connectivity will be of a paramount importance in connected homes, because 5G enables fast and high bandwidth communication.
So, and this vision that we now have for this port, and of course also for other sectors as well, I mean, be it factories or industries or cities, of course, partly relies on the communication of fiber. It also relies on the capacity of the 5G network to act as a cloud, distributed cloud environment. I didn't mention that before, but the 5G network will actually have compute and storage capacity all over, distributed all over the network. So you can actually put cloud applications in the communications network. And that is one of the ways where how you achieve these super short latencies that I mentioned before, sort of the sub-millisecond type of latencies. So in summary, I mean, we're only at the beginning of the digitalization of society. I mean, it's all over the place, but this is just the beginning. And 5G, the 5G network, the 5G technology is really one of the key catalysts, both for the connectivity itself, as I mentioned, but also for the cloud capacity running the software in the network. And of course, software is everything here. The hardware is of course important because that's where the software executes. But in the end, the challenge is really software. And Lenora is one of the key players in this whole scenario. Thank you.
Thank you so much, Bjorn.